Okay. First question for the 10.2 thingy. I don't know if this question changes if you get it wrong. Let us know. Just what this is easy, you know. And then for this one, this took me like 10 minutes of staring at it. I was like, what? This doesn't make any sense, but I figured out. I mean, oh shoot, now I figure out how to do this. Oh yeah, so what I did, if you can just look at the graphs and see scatter plot 5 and scatter plot 4, the slope of this is obvious. This is just 1. So for 4 you put 1 and negative, or 5 you put -1. And then for scatter plot 3, that's basically like the same thing. So I figured, it's like negative almost 1, 999 or 995. And then for this, it's still going negatively. Put negative. This is positive. So that's how I did that. If these are different and these numbers are different, there should be. All right, I'll just similar question. So okay, so scatter plot 3 is -1. 5 is positive. That's basically 1. 4 is all over the place. So it's -3. 2, positive, and then this one is negative 998. Should be good. Yes. There you go. That's that one. A little confusing, but it's really simple once you get it. Question 3. So it's the same as 10.2, but whenever you have these, it's always this answer. Equal sign, not equal sign, and both of these are 0. Show you. That one also 0. 5 will be, see, there's another one here. It's just going to be equal sign, not equal sign, and then 0. Back to here. For this one, this is just plugging the values here. Pretty simple. Luckily, yeah, 10.1, I remember how to do it, and it's pretty simple. You just plug in the values. Oh wait, I don't know why I opened StatCrunch. How do I get in? Oh, I'll just restart this. Similar question. Okay. Like I said, equal sign, not equal sign, 0, 0. For the correlation coefficient, it tells you, not too difficult. 0.74. So the critical values, it tells you it's plus or minus 0.268. If it didn't say plus or minus, the answer would probably be negative 0.268, comma 0.268. But since they have plus or minus, you can just put that as your answers there. And then this is where you need to have the paper, because no way I'm memorizing this. It's just on the paper. Is there sufficient evidence to support the claim? So with this one, piece of paper. So the professor gave 3 pieces of paper that explain correlation, and out of the 3, only 2 of them actually apply. The other, like the third page, is just a definition. The page you need is the one that deals with the R values. No, it's the one that does not have the p-value. So if you're looking at your 3 pages, the one that has the p-values is like the p-value is less than or equal to a. Don't use this page. The other one. It's the simple one. I hope I explained that well. So yeah, you just look at that piece of paper, and I think what you do, you're going to take this number, the correlation coefficient R, and see, is this in between, like this number, either negative 0.268 or positive 0.268. And this is obviously not in between that. That's greater than. So if it is greater than this or less than this number, you're going to have correlation. So yes, we have correlation because the absolute value of the test statistic, this, is more than positive 0.268. If this was negative 974, it would be the same answer because it still exceeds this value that is in between. So we're going to put that in 0.974. Okay. And then question 5, just words, language. When measuring an anestheticized bear, is it easier to measure chest size than weight? It is, because to measure chest size, it's easier than lifting the bear onto the scale. And you can also just think of this literally, like if you measure the size of a bear's chest, you're gonna get like generally what that bear weighs, just in general. That's how it works. The chest size could not be used to. You have to be careful. You want to pick the one that, yes, it is easier to measure chest size, but it could be used to predict it. Because think about it. Yes, however big the chest is, you're going to get an idea of how much the bear weighs. So that's the shit. Oh, it's the bottom one. Why? Oh, I wasn't reading. Yeah, that's also could not be used. So, yeah. Pay attention to your words, unlike me. That's the right one. Okay. And then this is like exactly the same, but we'll go through it anyway. Equal sign, less than equal sign, 0, 0. Test statistic is waiting. I'll figure it out. Oops. Because I forgot. Okay, I remembered. I just clicked view an example. It's this. That number and this number. But it wants to round to 3 decimal points, so we're gonna do 3, 7. Oops. There we go. Keyboard was bugging out. There we go. Okay. R, the test statistic, is these two numbers, which you have to round. Easy. And then the two critical values will be at plus or minus 0.274. I think it will not be 1. Oh, I think you have to look at the graph for this one. Value. Let me check. Okay, found it. Yep, I was right. You click here, the table. And it says 62. So we find 60 because it's close to that. And then the alpha is 0.05. So use this column, and it's 254. 254. Yep. And then state the conclusion, because the absolute value of the test statistic, which is this, is it's greater than this. Just, you can go ahead and put that in, because you know that's not going to be wrong. And then there, for this, you're going to have to use a little piece of paper. It should be the same one as question 3, the paper. You don't have to change it. Yeah. Okay, if it is greater, then there is yeah. There is sufficient evidence to support the claim there is linear correlation. Yes. Should be the answer. Yes, it did. Okay. And you just have to read the wording and make sure it is saying what you're trying to say. Sometimes it'll say, if you put there is sufficient evidence to support the claim, this might say is not. So you have to then also flip that too. So, question 5. Okay, this one's easier. Am I recording? Yeah. Yeah. Okay, this one, in my opinion, is even easier than these because just go to StatCrunch. Oops, should you open it with this little box? And then because it literally tells you it wants a scatter plot, click on scatter plot. Compute that. Then it's this one. Okay, and then the correlation coefficient, you go back to StackWrench. I should put it there so I can see it still. You go stat, regression, simple linear, x, y. These are the same steps as in 10.2. Compute. And the linear coefficient will be this, the correlation coefficient. 817. Okay. And then I think honestly for this one you can just look at it. You can look to see if that looks like it has correlation. Yeah, it's all in a straight line. They're correlating with each other, so could just put yeah, there's evidence, but then you wouldn't really know which one. Oh, it'd be linear. So you can choose that. Just look at the graph. But if you want to do it properly using the piece of paper, when you do this simple linear regression shit we just did with StatCrunch, you look at the p-value, which is this bottom one, and you compare it to the r-value. Is this... I want to make sure I'm doing this right. Oh, sorry. You compare the p-value to this, the alpha, which is it's always 0.05 in these problems. And that is lower than. So it's less than, and that means it supports the claim of a linear correlation. That's how you do it if you want to look at the numbers. But you can just look at it and get the answer quickly. Identify the feature of data that would be missed if part B was completed without without constructing a graph. This one's easy because there's this big ass dot over there. You would miss that the scatter plot does not reveal a perfect straight line and it contains one outliner. There you go. Here's like a little tip for multiple choice questions. This applies to literally everything. You can typically rule out which ones are wrong, like this one. Oh shoot! Wait. Scatter plot reveals a perfect straight line and does not contain any outline. You know this is wrong. I mean, you see it. I'm trying to figure out if it's B or D. I think it's D.